And even today in cosmology, we have a theory called inflation. It explains how the universe got very big very quickly. But we don't have a detailed mechanism for how it works. Another reason is that nutrients, you can't patent them. No drug company is going to run an expensive experiment to test the efficiency of a nutrient on an animal for humans, because it won't make any money out of it. The profits come from, or super profits, come from the patents. So they push drugs. I mean, I don't think I'm not saying there's a conspiracy here. I'm not one of these people that says big pharma is evil, but I think it's just a sheer commercial implication of the way the patent system works. Yeah.
But you can have patents in methods and processes as well, and from the sound of things, the mix of nutrients you would want during the course of your life may change, and so I would have thought there would be a big sort of managed care opportunity of basically saying through the stages of your life you need this amount of this at this age, and it'll change over time. And you could probably patent the process to enable that optimization.
You probably could, but then someone could come up with a slightly different mix, break the patent, I would guess. Well, who knows? I mean, I think it's unlikely that a company would manage to secure long-term profits.
Well, you have companies like Centrum, right? It's a branded vitamin, branded multivitamin,
that's right. Yep.
There's certainly profits to be
That's
had
true.
by vitamin companies.
Yes, okay, I mean, yes, okay, some branding will work. But they don't have, I would imagine, I don't know much about Central, or Solgar, or whatever, but I imagine they don't have the full power of the big pharmaceutical companies behind them. They produce things like, Viagra. Another reason is that it's just very difficult to run the experiments. They take a long time to run. If you've got a rat, that might live 4 or 5 years, and you want to test it for life extension, well, you might have to run the experiment for 6, 7 years, or 10 years. Now, a PhD is only 3 years, so who are you going to get to run these experiments? And they are very expensive because you need large samples, large sample sizes. You have to keep the animals in very, very good conditions for the entire period. Another reason is that people just don't find preventative strategies very interesting. All the attention, all the glamour goes on rejuvenation. And that's quite a natural thing as well. I mean, if I had a choice between taking a pill for all my life for slow aging, or I had a choice between a pill that regenerates me, of course I'd take the regenerative pill. So the funding goes into how can we reverse aging, SENS and other stuff like that. Not into how can we stay well, how can we stay well. Another claim often made is that there are lots of negative studies out there that show that it doesn't work, but they just don't get published. No one's interested in publishing a negative result, they say. But I don't believe that. First of all, it's an untestable claim. How can you demonstrate that negative studies don't get published? You can't. And the other thing is that if you read literature, there are plenty of negative studies that get published. So I don't believe that. Another claim is that you haven't really demonstrated life extension or slowing down aging. What's happened is that you've got your animals in a very unnatural environment, and the controls are all dying young because the lab is just a horrible place to live. And you give the animals the vitamins and the minerals, and they live a bit longer. But all you're doing is just correcting the fact that they're living in a horrible environment.
Actually, I remember one of Aubrey's talk. He mentioned that he gave one of the Methuselah Prize first endowments for something that showed that just changing the husbandry from a high stress to a low stress one, that gave 40% of life extension.
I mean, I know basically almost anything you do to the environment of an animal will cause a change in lifespan. So that claim's got some credibility. It does need to be examined, and I will look at that in a minute on some of the studies. Another claim, which is quite correct, of course, is that biology is just very, very complicated, and we're full of lots and lots of feedback mechanisms. So if you take large amounts of some supplements, all that happens is your metabolism will adjust to the higher amount, throw away the stuff it doesn't want. So, expensive urine and that sort of stuff. And you don't get any benefit at all. And then when you stop taking the vitamins, you get a rebound. Suddenly you find that the normal diet now gives you a deficiency, and you have to wait for a readjustment to happen, so you come off vitamins quite slowly. And this is cited as evidence that really you're wasting your time with vitamins. And the last one is that the whole idea is counter-evolutionary. We saw that developmental aging violated the basic ideas of evolution. And the idea here is that if aging is so easy to slow, why doesn't evolution do it for us? So let's look at some of those. So a bit more. So the fact we've got no model, it's a very complex system. It means that we can't say, if someone says, why are you taking that substance? Why are you taking glucosamine? Well, you could say, well, I'm taking it because it makes my joints a bit better. But at the same time, glucosamine also helps cardiovascular function. And that's what you would expect. Because as we said, we haven't got a simple one-to-one cause and effect model here. It's a complex many-to-many system, coenzymes and enzymes, there's a many-to-many relationship. And there's a heck of a lot we just don't know. So now we're dealing with the known unknowns, that come up a few times in talks here. So it's very hard for us to say anything sensible about what's going on inside us, why we take particular supplements. All we can sort of generally say is, well, I take the whole range because I think it's going to slow down aging. But I can't point to a particular one and say exactly what that one is doing. And scientists don't like that. The reductionist models that people like can't really handle the multifactorial nature of aging and biology in general, I think. Another problem is that people are still stuck in the deficiency mindset of vitamins. Vitamins were discovered by depriving animals of a natural diet and finding what diseases it caused. And so you have things like beriberi, for instance. Lack of vitamin D causes rickets. And if you don't suffer from a particular deficiency syndrome, then doctors have generally assumed, well, therefore you don't need a vitamin. If you're not pregnant, you don't need folic acid. If you've not got rickets, you don't need vitamin D. Until recently, they are changing their mind about vitamin D. This is to do with the poor environment one. Now, if the controls had reduced lifespan due to the fact they lived in a poor environment in the lab, and that the life extension we were seeing was just a correction back to the normal lifespan, it doesn't explain why these animals live longer than the species' maximum lifespan. We go back to the picture here. Here, when they gave them selenium, there were a number of different experiments here, which is why there was a range of results. But the best experiment gave a 48% mean lifespan extension. No, sorry, 9 to 16 mean expansion. 48% maximum lifespan extension relative to the controls, but a 43% extension relative to the whole species. So that means that the rats in this experiment, the oldest rat, lived 43% longer than any rodent that ever lived, any strain. So it can't be due to a poor environment in the lab. It's not possible. You can't get animals to live that long.
So if that were applied to humans, you could have humans living, other things being equal, another 40% longer.
60 years, but that would be the maximum lifespan. Yes. So some might reach that age just from taking selenium. Yes, possibly. And the same effect happened with chromium. We had a 15% maximum lifespan extension past the species maximum. So again, that cannot have been due to the fact that you either had a poor strain of rodent to begin with, perhaps you had a rodent that was particularly prone to die early, genetically, the whole strain, or perhaps they were housed in bad conditions. Well, that can't explain this result.
Are those two numbers active?
Which ones?
The 43 and 15%.
Well, see, no one's done the experiment. Don't know.
Was this done in the 1940s, or has it been
the mineral ones were done more recently. All the ones, and if you can see the number, all the one that says 1B in the corner, that was all one particular person experimenting back in the late 40s. No, the selenium, that was back in, I think that was back in the 60s. That particular one But they weren't interested in lifespan at all. They were just trying to test the toxicity of various metals. So selenium was just one of them. And
So-
they found...
So that was only done once.